Okay. Hello, juniors, and welcome back. I hope you had an awesome, beautiful, fabulous weekend. And if you can believe it, today is our last lesson of Unit 5. So this week you'll be doing this last lesson for Unit 5, and you'll also be working on like Unit 5 final activity. So those are your kind of two to-do list items for this week. So go ahead and get out a piece of paper or the notebook that you've been using to take notes and set up your notes. This is the last lesson of Unit 5. We are talking about cladistics today. So 5.4 Intro to Cladistics. And then I want you to think about or write down how do we visually represent relationships between species? You've seen cladograms before, even if you can't put the name to the picture. But I want you to think about how we visually represent those relationships between species. Pause, write a couple ideas down, then come back. Okay, awesome. So hopefully you wrote down some ideas about how we visually represent relationships between species. And feel free to pop into office hours this week to chat about this. My office hour times did change to match the schedule that Uplift has given you. So just make sure you double check those hours. They will be on Tuesdays and Fridays from 12 to 1 p.m. For my junior bio classes. So just a reminder, it's also in Google Classroom. Okay, let's jump right in. So our guiding questions for today. Number one, which features can we use to arrange species into family trees of related species? And how does the modern ability to analyze the DNA sequence of a whole organism help to group species? We're really just learning about how we group species and how we represent those groups. Today, it's our last topic of topic 5, which is crazy. We are really making it, getting through all these ideas. And why this matters in life. We must categorize life on this planet in order to make sense of the insane amount of species we have on Earth. If you remember, we have recognized and described 1.2 million species, but it's hypothesized that there's over 8 million species on our planet. And without categorizing those, scientists wouldn't be able to study or write about the vast diversity of life that we see on our planet. And then me trying to figure out a cladogram, like, but you're not going to look like this by the end of today. You're going to totally understand cladograms. So let's jump in. Sadly, I am not there and we are not at school. My original plan was to give you all of these cookies and you were going to get to sort them and then eat them. So I am very sorry. Don't eat my virtual cookies. LOL, haha. But if you have any cookies in your house, you can go grab one and give yourself a little treat after this little activity. So what I want you to do is make a cladogram with the 7 pictures of cookies that I linked on a document. This is just like a little get your brain going activity. So you can just write it on your notes as like a little scrap sheet of paper. Not anything you have to turn in, but it is cool to do. And then I want you to think in your head or write down the answers to the questions on that document after you've made your cladogram. So I'm going to show you what that document looks like right now. Oh, you got to see my whole, where is it? Virtual cookie cladogram. Okay, so this is what that document looks like. Let me zoom in a little bit. There we go. So you are going to use the types of cookies that you see right here and sort them on the cladogram on this back page. You can draw the cladogram on your notes and just add in the names of the cookies. So we've got crunchy chocolate chip, oatmeal frosted, fig bar, regular Oreo, chewy chocolate chip, vanilla Oreo, and Oreo double stuff. So first you're gonna pick out one of the cookies that you feel like is most different from the others, and then that one's gonna go in the top left of the cladogram. So that one would go right here, because you're saying that one is most different from the rest. Then you're gonna choose the next most different and put it on the diagram, and you're gonna continue adding cookies to your diagram. And if you find that there are 2 or 3 cookies that are super similar, then you're gonna have to add lines to your diagram to show that those cookies are super similar. And then you can review your selections and check that there's not a simpler solution. So this is an example of what a cladogram looks like. And I'm going to go more into depth about what these mean, but it's fun to try it on your own before we jump into what they actually mean. So if you draw something like this in your notes, that would be perfect. And then as you notice, there's only a spot for 4 different cookies here. So what you're going to end up having to do, and I can draw it for y'all here, is draw lines to show cookies that are more similar. So let's say that you think the oatmeal cookie and the fig Newton are really similar, but you want to put them over here, then you're gonna have to draw a line and add that other cookie right here, or draw a line here. You can even draw multiple lines like this. Just to show how things have diverged from a common ancestor. What I do want to tell you, and be careful about this, is if you draw a line like this and it ends here, then you're telling me that this species of cookie is extinct, no longer, like it no longer exists in the present, because on a cladogram, this represents time. I'm trying to write very carefully. Ooh, that was kind of good. I'm getting better at this. So as you move this way, this goes from the past to present day up here. So if you end any line before present day, that is sometimes correct. That's just telling you that that species is extinct. So if your species of cookie is not extinct, then that line needs to go all the way to the present. Okay, I'm going to erase all this craziness, and go ahead and pause me and do this little activity, and then come back and we can keep talking about it. So hopefully you are back and you have made your selections. I'm wondering, how did you sort your cookies? Why did you sort them in that way? And what would you do if I gave you a new species? So make sure you have some ideas about that. We can talk about that during office hours. Okay, the whole point of that activity was just for you to take time thinking about, okay, what similarities and differences do I look at in order to sort different species? So yes, I know that we're not talking about real species in that activity, you're talking about cookies, but what did you look at in order to sort them? A lot of people, when they sort these, the immediate one that they feel is really different is this fig Newton. Why? Hopefully a lot of you said, oh, it's different because the fig Newton is a square and the rest of them are circles. So I'm going to make fig Newton the most different. So you start with a really basic criteria like shape, and then you start to move into, okay, let me group them into ones that are similar. A lot of people then group the Oreos together because they're really similar, and they group the chocolate chip cookies together because they're really similar. And so it's just thinking through the different ways that we group organisms. But your only note for today, like literally only one slide of notes, is right here. So make sure you pay attention and get these notes. What is a cladogram? A cladogram is a tree diagram that shows the most probable sequence of divergence in clades. And you're probably like, thanks, Miss Panzer, that did not help me whatsoever, other than the idea that it's a tree diagram. So what is a clade should be your next question, because you're probably like, I've never heard the word clade, so what is that? Well, I'll tell you. A clade is a group of organisms that have evolved from a common ancestor. So essentially, a cladogram is taking a whole group of organisms that evolved from the same common ancestor, and it's going to show the way that they diverged over time to become their individual species. Evidence for species of a clade can be based on two different things. Well, a couple more than two different things. But this is an important distinction to understand here. So evidence for species of a clade can be based on the base sequences of a gene or the amino acid sequence of a protein. And if you are really connecting the things that we've learned in this class, like all the way back to Unit 2, you know that these two actually are really closely related, but are not always exactly the same. So let's just go way back to Unit 2 and recall the process of, recall the central dogma. So where we take DNA and transcribe it to RNA and then translate RNA into protein or amino acids. So the base sequence of a gene is going to be made up of those A's, T's, C's, and G's. Hopefully you remember that, right? And this base sequence of DNA is transcribed to RNA. So that A, T, C, and G, A would pair with what in RNA? If you said you are remembering things and doing awesome, so keep it up. If you did not say you, that's totally okay. That just means we need to review. T would pair with what in RNA? A. C would pair with G. NG would pair with C. Remember, apples in the tree, car in the garage, or apples under the tree, car in the garage. And then this RNA is going to translate to amino acids, and you have to use a amino acid chart in order to do that. Let me pause and pull up an amino acid chart for y'all. So I actually realized if I change my, oh no, exactly what I thought was going to happen happened. Dang it. Okay. That's okay. We are rolling with the punches here. So if you remember, I had A, T, C, G goes to U. I know that's an awful U. Oh my gosh. U, A, G, C. So if I pull up the codon chart, all the writing goes away, which already happened, which was a little bit annoying. I'm actually going to write this way. But if you look on a codon chart, UAG actually is a stop codon. But it's the stop amino acid or stop codon. But still, what I want you to think about is the fact that evidence for the clade can be based on the base sequences or the amino acid sequences. And although the base sequences and amino acid sequences are related to each other, it's important to realize that the base sequence and the amino acid sequence can be different sometimes. So, for example, if I pull up a codon chart for us and we look here at this codon chart, yes, okay. If you look here at CCU, CCC, CCA, and CCG, all of these codons code for the same amino acid sequence. So the base sequence might look different, meaning that the individual might have a U, a C, an A, or a G at the end of that codon, but it's still coding for that amino acid proline. So your base sequence and your amino acid sequence are similar, but not always exactly the same. I know that's a little bit confusing, so if you're struggling with that concept, please come into office hours so that I can try and explain it a little bit better, a little bit more clearly for you. But basically, back to our one slide of notes that's taken quite a while. There is a gradual accumulation of differences as species diverge, and a positive correlation between the number of differences between two species and the time since they diverged from a common ancestor. So this is just saying that if we look up here, the sharks are going to have many more differences that have diverged from birds because they diverged further in the past, meaning that they've evolved more differences. Whereas the birds and the crocodiles are going to have evolved less differences because they evolved more recently. All right. So that is your one slide of notes today, and I'm going to pop through, explain the activities before I go. So activity 1 should be pretty simple and pretty quick. You're going to use the slides that I've linked on Google Classroom, and the slides are labeled activity number 1 slides, and answer the questions on the Google Form worksheet. You're basically going to look at a bunch of different cladograms and answer some questions about them. Here are what the slides look like, just so you know. So you have cladogram 1, and you have questions on cladogram 1, cladogram 2, and questions on it, 3, 4, 5, and 6. So you're just going to look at those slides and answer the questions about each individual cladogram. Once you finish activity 1, then you're going to do activity 2. This is where you're going to use the link on Google Classroom to the Understanding Evolution website, and you're also going to use the activity number 2 worksheet. And basically, you're just answering the questions about evolution and cladograms. This is a really good summary activity for kind of everything that we've learned so far. The website looks like this. I also have it right here. This is what the website looks like. Understanding Evolution, and there's a lot of information on it. So make sure you're just looking through and answering those questions for activity 2. And then when you finish and you feel really confident, go ahead and do exit ticket 5.4, which should be pretty simple. It's on cladograms. It shouldn't be too complicated. It's basically just reading these diagrams. And if you need help or want to go over any of this material, please log on to office hours with me on Tuesday and Friday from 12 to 1 p.m. If these times do not work for you, just shoot me an email or a remind message, and we can schedule a time to meet virtually that works best for you. But I am looking forward to seeing all of your responses and I'm looking forward to seeing you guys in office hours. I miss you all, and can't wait to connect with you this week. Have a good week, y'all. Make today awesome.